Hello, everyone. So I see some people still coming in. So I will talk about CERNBox and the operation at CERN for this service. So I'm the responsible for this service, but we are actually a team of 3 people working on that, 3.5 people working on this. And basically today I will describe a little bit the architecture of the system. I will show you our user community and the new feature we are planning and we're putting in production, and then an overview and a summary. So first of all, what is CERNBox? So CERNBox is the CERN cloud synchronization service. This provides to all our users 1 terabyte of data, and it helps our user to synchronize the file against our storage. And for a user, it is an easy way to share their files and their document. And it's supported by all the main platform. And it's based on cloud integrated with EOS, with our storage. So this is CERNBox, and this is our physics storage system. So what it is EOS? You have seen this morning the presentation from Andreas. So basically, we currently reach 1 billion files, 95 million directory, and we have 110 petabytes of actually used space. So EOS is the CERNBox backend, but is also the backend of all the LAC and physics data. And the deployment is across 2 different computer centers. So what in generally do, we do a copy in each of them in order to preserve the durability of the data, and also to have a short latency in accessing the file from both sides. So this is the CERNBox architecture. So this part in the middle is what we call CERNBox. So we have our own cloud and CERNBox synchronization client that talk with our HTTP load balance Nginx server, which then redirect them directly to the storage node of EOS. So EOS keeps the entire namespace. So this means we don't need any file cache from on cloud. We don't need any part for this particular database. What we use is basically the web front end of OnCloud and the sharing database, so the OC share. So people, when they enter, they enter from this path from the web browser, and they can see their share and they can see their file, and OnCloud talk directly with EOS. So EOS is able to speak directly the OnCloud HTTPS protocol. So in addition to this, it's also possible to access the system and to have the same view from Fuse clients and the EOS and X3D native client. So what we did this year in addition, we also set up a Samba gateway in order to have the same view, online view also for Windows Share. So we have a particular server that export EOS via Samba. And for this, it's possible also to, for the future, the plan is to basically get rid of a part of our DFS storage system. So our community. So last year, when we presented, we had 4,000 registered users on the system. Now we have 8,000 of them. The number of files drastically increased. So the user just doubled them. But you can see that the files are more than 3 times more. So we have now 175 million files only for our user community, not taking care of all the parts from the experiment, which are many more millions of files. So here you can see how the number of files grows. So it's not really a linear growth. And here how our user grows. And this is the growth per week. So you see that in some week we got some high jump, and this is usually when there are some events and people see that there is a new service that they can play with, etc. The current raw space used by the system it moved from 200 terabyte last year to 800 terabyte, and the actual deployed space is 3.2 petabyte. So the system is not only for our physicists, but is also for our administration people and for our engineer, for the services, etc. So we have a various community. So last time we checked, we had something like 60% of Mac user, for example, and 20 of Windows and Linux. Now more physicists are joining, so the ratio for the Linux people is increasing a bit, but still we see a quite huge usage for Mac user. And this is where all our clients are from. So we trace basically the first 6 months of this year. to see where our people are connecting from, where they're sharing, etc. You see there is a huge part in the continental Europe, but we also have clients basically spread all over the world. And this because CERN is not only the CERN employees, but we have a lot of physicists which are basically distributed in all the different universities in the world. And one of their main target is share information in order to analyze data and basically bring their work forward. So this is one particular example. So in Chicago this year, there was, in August, there was a special conference for physicists. So this is the main physics conference if you talk to one of the physicists. And it was during this period of time. So what we did, we checked a little bit the usage before the conference and during the conference. And you see from this heat map that during the conference, there was a lot of exchange of information with CERNBox between physicists, sending papers, sending presentation, and other type of data between them. And that's quite interesting because we can see during all the weeks how I was doing the work between them and see how much they were using the system and helping them for the conference in order to prepare, so sharing all the information before the actual conference. This is a snapshot of the last 7 months. So this shows all the unique IP daily that connect to the system. And here you can see how many put and how many get we have in the system. So we can see some daily peak of 1 million get and a bit less of put every now and then. We're not yet at the level of Dropbox, but still we have a good number of users. And you can see the top image. You can clearly see that we have a baseline of desktop and sync line which are always connected. And then you have a kind of weekly cycle and a daily cycle where people comes in and they connect with their laptops and mobile, etc. And this is only active basically during the working hour of the day. You can also see a dip, August holiday. You can see here there is a quite deep hole. And you can also see another very big dip here. So during Christmas time, CERN is closed for 2 weeks, and during these 2 weeks, you can see that all the mobile user, all the laptop user, they were not working during this period of time, while we kept continuously the baseline of the desktop. So concerning the HTTP operation, what we see is usually a quite background of prop find. So this is the sync client, which is probing if there are new files coming, new files available that needs to be synced. And this comes between 60 and 80 hertz. Some of the peaks here are cut because we shrink to the last 7 months. And if you see in detail, so this is a zoom of this little part here, you can clearly see that this is Monday, Tuesday, Wednesday, so you can see each daily work and then the weekend, which is a little bit low. And you see the activity, how it goes during all this period of time. So all these these are all the put during the day, and you can also see all the rest. So in general, the system is quite used. And basically all this HTTP activity is handled with only one server at the moment. I mean, we have a backup server, et cetera, but the load we receive from all our clients currently is quite easy to sustain. So in case our user base just double it, etc., we just don't need to instantiate several DB server or several particular server. We just need another HTTP load balancer, and we manage the traffic. So we'll now show you what we are working on, or what we did during the last year. So we enable single sign-on for the web interface in particular, in order to align the web interface to the web standard at CERN. So everything should be single sign-on with shibboleth, etc. So we enable only for the web interface. And the desktop sync client is continue using the standard authorization for the time being. We'll probably plan in the future something in that direction, but is not sure yet, and it will take some of our spare time. So another feature that we are planning, we actually have it ready, and we will put it in production in the next couple of weeks, is the gallery view. So since we don't use directly the on-cloud file cache, etc., some of the caches for the images, etc., we have to do them on our own. So we have to change a little bit the different API from the web interface to talk with our backend storage and to provide all these images, all the preview, etc., to be fully integrated with our gallery app and our storage system. So this will be the next big thing for a user, because now they will be able to upload even more image than what they do right now. The next improvement, so Andrea briefly mentioned it this morning, so will be on the file system access. So these are the last 6-7 months, and you can see this is the usage only with the Fuse access, and you can see we start having a kind of exponential growth with the Fuse client. So with the next release of our Fuse module, we'll plan to have even better performance, and this will allow our user to use even more the system and probably create even more million and million of files. So the important part here is that we enable our user to have the same view from all the different devices. For example, a user will just generate a file on their local Mac or on the local machine, etc. This will be synchronized, so it can be visible and maybe shared to another user from the web interface. But this will be also available directly accessing the Fuse file system mounted on all our machines in the batch system, for example, and therefore launching thousands of jobs that reads this data and process it. Still on the Fuse, on the file system access, as I mentioned before, we're going with the Samba gateway. So we had a lot of interaction, etc., with our DFS community and our DFS colleagues. And basically, we realized how much powerful was this integration between this single view and the synchronization client and the batch access. So everything integrated in a single view, in a single namespace, is quite powerful, because then you can have your home directory both on Windows, on Mac, on Linux, etc., that share the exact same view of your files. And this is quite tempting also for the user. So what we did for the Samba, we create a Samba gateway, still using a Fuse. So we create a Fuse layer, and then on top of it, we provided a Samba server that was exporting basically the mounted file system to the client. And then the client, they pass just via this gateway, their map as themselves, they are authenticated, and then they can access the same storage system that is visible also from all the other sides. What we are aiming basically is to have a full integrated system with all the different services at CERN. In particular, having the web interface as a single point of entry for our user, and then redirect them, depending on the file type, on what they plan to do, etc., to each other service. So have a kind of self-service when you have your file, and then you know that this is a Python notebook, so I can open it. And if you just click it, we have a read-only view, basically. So we display the actual content of the notebook, but if you want, you can actually open it. And as was described yesterday by Enric and Danilo, you can open it in Swan, and this will actually enable you to run directly on the Swan service this particular file. So you can share your Python notebook with colleagues, etc. So you can also show what you did for your research, etc. And then you can see it, but you also can execute it, and you can modify it. You can modify, you can refine it, you can simplify it maybe, and then reshare it again, or give back the feedback to the original author of the notebook file. So this is very powerful for our scientists and for our physicists to share their actual work and to enable them to go to a step further. So not care about all the lower level part, but just caring about their main work, which is about this analysis. So going this direction for the integration from this single point of entry, which is the web interface, the next step is also the documents, because lots of our administrative users what they do is they use SharePoint, Indica. We have several services, etc. And they use a local Windows, then they use DFS, etc. But at the end of the day, they just want to share and use between them the same Excel file or a PowerPoint file, etc. So what we are doing right now is setting up basically an interface that will, with this API, which is the Web Application Open Platform Interface protocol, so we'll be able to talk directly with Office 365 and using basically all the feature, all the possibility that the Microsoft Office allow, integrated with our own cloud front end. So we are currently working on this in order to enable all our administrative staff to basically improve their work in, with all this document suite. So just an overview of what I said and a summary. So EOS and CERNBox are a quite innovative platform for the scientific computing, but not only for the scientific computing, because we have a good part of our users which are not just physicists or engineers. So this enabled them to simplify their work. And in particular, we have also a scalable architecture that we are able to grow and shrink on demand and depending on our user demands. We have a full integration as well, not only with user data, but also to a 100 petabyte storage system, which contain all the physics data, which is quite powerful. And basically, our goal is to bring the data closer to a user. So why not enabling a CMS scientist to have a local copy of the data he's working on in order to test and try out some analysis job, for then running it with just a click on a large-scale batch farm, and this seamlessly from his own laptop. So new way to interact with the data, a new way to bring this data closer to a user where they actually need it. So you can see CERNBox in our future plan as an extension of the user desktop, and that's why we are trying to integrate with as many services as we can. So that's why we went on the direction for the WAPI server, so for the Microsoft 365, and for Swan, and for each other services that might be useful for a user. And this is one of our user feedback. I don't know if you can read it from far, but this is a second feedback. He first sent a feedback, and then he sent another one. So he wrote, again, this is really amazing. I'm figuring out now what I can do. Freedom. So for him, it was quite interesting to have all this possibility to access his own data. So thank you for listening. If you have any question, feel free to ask.
Thank you, Luca, for this interesting contribution. And I believe there are questions to Luca.
Hi, thank you for a great talk. Sorry if I missed this in your presentation, but do your users get to access Samba and other services outside of the CERN network?
Yes, except for Samba. Currently, Samba is only available inside CERN network. But the plan is to make it available also outside. Yes.
Oh, cool. Thank you.
Just come.
Could you comment a bit the increasing usage of Fuse for your user? Because we are speaking about object, but Fuse is mostly about traditional POSIX file.
So our user traditionally love POSIX file system. So that's why when they saw it, that was available, they just start using it. And that's why it start growing so rapidly.
Why our own cloud?
So when we started, we did a survey of the different alternatives that were at the time, and we thought that own cloud was the one that was best fitting our user community. And we started a special relationship with them, and now we're here basically. But in particular, what we really like is that in our particular setup, we only take care of the server part, let's say, while for the clients, these are just standard on-cloud clients, so we don't have to really develop them. So this is the good part we're taking from this relationship between them and us.
Oh, thank you very much.